So then if we can imagine a directed line going from the origin to each of those points, you can see that we've got the arrows here. That's the directed path going from the origin to each of those complex numbers. Now if we add the complex numbers together, what we do is use something, it's often called triangular properties or triangle properties of a vector when you're adding. So if you can imagine picking this vector up, okay, actually picking that up and placing it so that the end of it, now with vectors, we haven't looked at these yet, but we've got two parts of a vector. We have something called the tail, excuse me, it's very poorly written, and the head of the vector. The head is the arrow end. So what we can do is, if you can imagine picking this vector up and actually placing it so that you've got Z1 here, plus we're going to add this vector onto the end. So if you can imagine sitting that vector, actually taking it up from here and putting it here, so that we've got head to tail, where that vector head ends would be where Z1 plus Z2 is. So the vectors draw out the path. Okay, and because addition here can be done either way, you could have Z2 plus Z1 as well. Z2, and then if you picked up Z1 and you actually put it here, okay, you'll end up in the same place because you'd have Z2 plus Z1. That's the interesting thing about vectors. You end up in the same place with whichever path you go here. So that's the idea with adding. You're using that triangular type of property there for adding. The other type of property that's interesting is when you multiply. Okay, so if you have a complex number which we'll call Z, okay, which sits here, imagine again, let's draw ourselves a little vector which points to where Z is. Okay, so if we multiply by a number which is bigger than 1, so we're going to multiply by a scalar which is bigger than 1, what that will do is it will actually stretch this vector and make it bigger, or stretch the point out so that it ends up in a place that's further away from the origin. So it's a stretch. If you think about multiplying your complex number by a number that is in between 0 and 1, so that would be a positive fraction. So like a half or a quarter or whatever, you're looking at a smaller percentage of what you started with. So you'll actually end up shrinking your original point Z. So you can imagine it's a smaller point there like that. Okay, the last thing to consider is if you're looking at complex numbers and you multiply your complex number by a negative number, what that will do is it will actually turn around your Z, okay, so it will end up going in the other direction, so it will end up sitting over here. So that's the idea with multiplying with vectors and also with complex numbers. With complex numbers, we're only interested with the actual points, so CZ, BZ, Z or AZ. With vectors, we're interested in the arrows as well that tell us the direction of that point. So now what we're going to do is use that knowledge and that understanding of triangular addition, also multiplication, to work through this example. So we've got two complex numbers. We've got Z1 equals 2 plus I, and we've got Z2 equals negative 1 plus 3I. What we want to do here is we want to represent Z1, Z2, Z1 plus Z2, and also Z1 minus Z2. We want to represent those on the argon plane. Remember that has the imaginary and the real Z as each of its axes. So what we need to do is first of all figure out Z1 plus Z2, which we can do. We just add them together. So add negative 1 plus 3I, and you'll get 2 minus 1 is 1, and I plus 3I, there's 4I there. For Z1 minus Z2, just be careful that you use the brackets so you can make sure that you're not going to do anything wrong with the signs here. So you're going to have 2 minus minus 1 is going to be 2 plus 1. So that will be 3. You can expand this out too if you want to see that more clearly. And I minus 3I will be minus 2I. So we've got our two different vectors now for the addition and the subtraction. So what we want to do is now put them on our graph here. So first one is Z1, 2 plus I, which would be 2 plus I, which gets us there. So that's Z1. Z2 is negative 1 plus 3I, which will be here. Oops. That's Z2. Z1 plus Z2 is at 1 plus 4I. So that's actually going to be up a little bit higher. I'll just move this out of the way. Let's move this up a little bit. So 1 plus 4I will be here. And that's Z1 plus Z2. And the last one, Z1 minus Z2, is 3 minus 2i, which would be here. Okay, so that's Z1 minus Z2. I'm also going to put down, I don't think it actually asks you to do this, but I'm also going to put down what minus Z2 is as well. Minus Z2 is just everything in here, all the signs are opposite, so 1 minus 3i. And the reason that that's going to be interesting, 1 minus 3i is here, 1, 2, 3. That's minus Z2. Is we'll be able to actually see a bit more about the triangle addition properties when we look at this now. So we've put our complex numbers down. Let's have a look. We've got Z1 plus Z2. Now remember from what we looked at before, there's Z1 and there's, do that a bit better than that, there's Z2. So if you draw straight lines and you can imagine some vectors going that way, if you were to pick up Z2 so that you had Z1 plus Z2, it would be running parallel to that line and it would actually get us to where we wanted to be, which is Z1 plus Z2. Okay, so if you can imagine that as a vector Z1 and that as a vector Z2, then we end up where we want it to be. Okay, again, if we go the other way, we've got Z1 take away Z2. Now you can see why I put the take away here, because if we go Z1, Z2, this is take away Z2 here, so this is actually going this way down to there. So if we run from the origin, we go Z1, take away Z2, that's a vector that would look like that, that would be take away Z2, then we would end up at Z1 minus Z2, which gets us here to this point. So you've actually shown that you can get to each of these using the point Z1, Z2 and negative Z2, using that triangular addition that you will be looking at in vectors. Okay, so using the different properties of addition here and being able to display complex numbers on the Argand plane are the key points.